Hi everyone, I am Sudheer Gupta, teacher in Study Hall, Lucknow. Welcome to my channel School Jaisa. Support me with your like, share and subscribe. Thank you.
Continuing with the same chapter, force and pressure, this is the sixth part of the video. Now here we are going to study about the pressure exerted by liquid. Till now we understood that how the pressure is exerted by any solid substance. Now is the pressure also exerted by liquid? If it is exerted, then how it is going to be exerted? That all we will study over here in this video. So here what I did, I have taken a glass tube, and in the first glass tube which was open from both the ends, then I tied a balloon at the base or one of the end, that is on the lower end, and then later on I started pouring water into it. When I started pouring water into it, then what was the observation? The observation was the balloon started bulging downward. The balloon started bulging downward. Now the question comes, why the balloon started bulging downward? What was the thing happening? So here we come to know, till no water was there in the tube, no bulging of the balloon was there, whereas as soon as the water started going to be get poured into it, the bulging started. It tells that the liquid apply the pressure at the base where the balloon is fixed. So here we came to know the liquid applies the pressure at the base. So this we came to know with the help of this activity. Now what we are going to do, again we are going to take a glass tube. So again when we take a glass tube, which is going to be open on from the top but the base is closed, but it has a tap opening, that is the opening from the side, and on that opening which is there on the side, we tie a balloon. Now initially when we have tied the balloon, we observe no bulging was there, but on pouring the water into this tube, definitely it must be applying the pressure at the bottom or at the base. But what do we see at this position? That the balloon started bulging outward like this. So balloon when it started bulging outward like this, then what comes in our mind? That in this case the pressure was exerting at the base, but here the base is closed and the balloon is on the side, and even then the balloon is bulging. So it tells that pressure of the liquid do not get exerted only on the base but also on the sides or on the walls of the container. This is the reason when the water tried to come out, then the balloon which was fitted, which was tied on that opening, that bulges out. So we conclude with the help of this activity that the pressure of liquid is not going to be acting vertically downward or at the base, but also the pressure is exerted on the wall of the container or on the sides of the container. Now we come to the next thing. Here what do we see? A water bottle structure like this, which I kept under the tap which was continuously giving the water, and I made some holes over here, first hole, second hole, third hole, fourth hole, and when I was continuously allowing the water to fall in the bottle, what was my observation? The observation was the water was coming out with a greater force from the hole which was at the maximum distance from the free surface. This is called the free surface of the liquid, means the top surface of the liquid. Means what I observe, that the hole which is going to be at the maximum depth or maximum distance from where? From free surface, from top surface, the water comes out with a greater force, whereas the hole which is going to be very near to that of the free surface, which is at to the least height from the free surface, the force was there, but it was the least one. Now how do we come to know that the greatest force was there at the bottom hole and the least force was at the top hole? Because we see at the bottom hole, the water which gushes out, which comes out, it is covering the more, it is falling at a greater distance, whereas the water which is coming out from the top hole is falling or covering a very less distance when it falls on the ground. So it tells us that as the height increases, as the depth increases from the free surface of the liquid, the pressure increases. So here we conclude that as the height increases, pressure also increases. That is, pressure exerted by the liquid depends on the height of the portion. That means more the height from the surface, more will be the pressure. Now we take another example. Let us take a container in which again we allow the water to be getting filled into it continuously. Tap was open, but here what I did, I made the hole at same height. That means this distance, this distance, this distance, this distance, all were same from the free surface. That is the top surface of the liquid. Now when the water was coming out from the hole, it was observed that the water was falling at equal distance on all sides. That means it's not like this, that somewhere the force was greater and somewhere the force was lesser. No, equal amount of the force was acting by the water on the whole hole, all the holes, and due to which water which comes out or gushes out, it covers equal distance. That means the water was coming out with equal force. So it also confirms that if the heights are same, then pressure exerted would be same, but if the heights are varying, then the pressure exerted on it will also varying. How? That we have understood with this, that as the height from the free surface increases, the pressure also increases.